Hi there and welcome to video number 31. This video is on powers and indices rules. Now this is what could be considered an algebra topic a little bit later on down the line, but I think for the grade 4 stuff that I'm doing here at the moment, it's still in the number section. There will be a grade further than that, 8 7 stuff, grade 70, 80 sort of area stuff for algebra. And we're touching upon the algebra here, but this is still more firmly fixed in the number section for me, right? So the keywords here are powers, indices, exponentially, base, reciprocal, simplify, evaluate. Quite a few keywords there. So powers are numbers that make, the little numbers that are next to the base numbers, the whole ones, the big ones. And they make numbers get bigger really quickly. Mathematical shorthand is what they are. Indices are the same thing. Exponentially is it means when something grows really quickly, so it starts to get bigger a lot quicker. So if your money grows exponentially, great, wonderful. That means you're getting a lot of money quickly. Base is the base number is the number that is next to the power, the big whole one, right? The bigger number. That's what we refer to as the base number. The reciprocal is when you turn a number upside down. So if you've got a fraction of 1 over 4, 4 over 1 is the reciprocal of that. Or if you've got a fraction of 5 over 3, the reciprocal is 3 over 5. Okay, so you turn the number upside down basically. That's what reciprocal is. When you simplify something, you're just writing it in a simpler way. All right. In fractions, you write them with smaller numbers. In algebra, you simplify by making it easier for you to understand by getting rid of all the stuff that you don't need. When you evaluate something, you are working out the final answer to it. You're calculating it. Okay, so I've kind of bumbled my way through those explanations. Now, when you are looking at the method here, what I've done for the method is I've written 7 rules. Okay, now writing numbers in index form with powers is mathematical shorthand. That's the first thing you need to know. Okay, it's not really necessarily a method, it's just things you need to remember, things you need to learn, all right, which will allow you to answer these types of questions. Now, rule number 1 is anything to the power of 1 is itself. Rule number 2, anything to the power of 0 is 1. Rule number 3, 1 to the power of anything is 1. Okay, so 3 very, very simple rules, those ones. That's in box number 1. Then in rule 4, I've got when multiplying and the base numbers are the same, you're allowed to add the powers. When dividing, you can subtract the powers. Obviously, the base numbers have to be the same there as well. And when raising one power to another, you can multiply the powers together. You'll see those examples in question 2, along with rule number 7. When the power is negative, you need to turn it into a reciprocal. That means you turn the number upside down. I'll talk about what that means in real terms when we get to the question. So when you're evaluating number 1, that means working out the answer to, the actual numerical answer. 34 to the power of 1, well, let's look at our rules. Anything to the power of 1 is itself. So the numerical answer is 34. It is itself. Whatever that base number is your answer. If it's to the power of 1, you won't see numbers written like that because they're just written as themselves. Okay. But if you are doing a question and you end up with something with a little power of 1, you know that it's itself now. Now, this one's a bit of a weird one. We can explain it using the other rules, but we won't bother. It's just a very simple thing to remember. Anything to the power of 0 is 1. So 17 to the power of 0 is 1. There's our answer. That's a very strange diagonal 1, but I've told you it's a 1, so it's a 1. Right, now C, 1 to the power of 23. 1 to the power of anything is still just 1, because what you're doing with powers is you're multiplying the number by itself and then itself again and itself again. We're doing that 23 times over. So 23, so 1 times 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 1. No matter how many times you multiply 1 by itself, it will always be 1. Okay, so there's the first 3 answers and the first 3 rules. Now in box 2, I've got some slightly more complicated but not too bad questions. Rule 4 is applied to this question. We've got 2 as a base number and 2 as a base number. I've written write the following as powers of their base number or simplify, because you can do different things with these. You'll see those questions written in maybe one of those 2 ways. So we're just going to add the powers here, and that's going to be 2 to the power of, and then 4 plus minus 8. So if you've got 4 plus minus 8, it becomes 4 minus 8, and that will give you minus 4. Okay, now we could evaluate, or we could simplify that further, right? But I won't do that for this example. I'll go and do that down here when we've got this negative power down here. We've got b, and b is 5 to the power of 6 divided by 5 to the power of minus 2. Well, we're now going to have 5 as the base number of our answer, and 6 minus minus 2, right? Because we're dividing here and we're allowed to subtract the powers. 6 minus minus 2, two negatives stuck together becomes a plus, so that's 6 plus 2, and that'll be an 8. Okay, so I've put some deliberately slightly more awkward questions in there with adding and subtracting positive and negative numbers. If you're not sure what I've done or why that is the answer, please go and watch that video I've made on calculating with positive and negative numbers. It's one of the first ones in the number section. C is one where we're going to do the raising, raising one power to another, but I've introduced a little bit of algebra here. I put a little a in there. All right, now 4 is a number that we can put to the power of 4. All right, now what is 4 to the power of 4? Well, 4 times 4 is 16, multiplied by 4 is 64, and then 64 multiplied by 4 is going to be, I'm not sure, what is 64 multiplied by 4? 60, 6 times 4, 240, 200 and something, 256, I think. So 256, could have done an easier example, 256, a squared, then this is the bit where I was really getting to, we can multiply these two numbers together. So that's going to be 256a to the power of 8, because 2 times 4 is 8. Okay, might have got that bit wrong. If I have, I'm going to remake the video. That'll be annoying. I hope I haven't. I hope you see this bit, right? It's me struggling with doing some maths. Now, D, this one is just the same as B. It's just a dividing question. 3 to the power of 11 divided by 3 to the power of 3. 11 take away 3 is 8. So 3 to the power of 8. Okay. This one looks really complicated, but if we split it up, pretty simple. Okay, again, we've got the element of algebra in here with x's and y's. Don't be scared. They're just representative of unknown numbers, and you'll get to understand that when I make more algebra videos. So we're going to do, and this is a multiply here, not an x. No, it looks the same. I'm sorry. But 2 multiplied by 5 is, I have put spaces in there. 2 multiplied by 5 is 10. Okay, so we've split the number bit, multiplied by the number bit. We've got the x to the power of 1. Remember, there's a 1 next to that x there that doesn't exist. Multiplied by x to the power of 4. So I'll just write down x to the power of 1 multiplied by x to the power of 4. So you can see that we can add those two powers. That gives us x to the power of 5. Now, I write x's with these curly backwards c, forward c stuck together, looking x's. But obviously, I can't type those into the computer like that. So that's how I'm writing those. And then y to the power of 5 multiplied by y to the power of 3 is y to the power of 8. So splitting it up into those 3 bits, you can piece it back together, and we've simplified that expression there. Now in F, we've got 7 to the power of minus 3, and that's the one where we turn it into a reciprocal. Basically, turn it into a reciprocal, we're going to put 1 over, so 1 over, and then 7 to the power of positive 3. Okay, so 7 cubed. We might be able to evaluate that, in fact. It doesn't ask us to, but we could, if we know what 7 cubed is, it's 343, if we know your cube numbers. And then we got 1 over 343. Okay, now in the last bit, I'm trying to keep the video as short as I can, but find 3 different pairs of values for P and Q. Now P and Q are the powers of 9 here, and we end up with 9 to the power of 16. So this is just us being able to understand rule number 4. All right, you're allowed to add 2 numbers to get 16. So it could be that you add 2 and 14. All right, P could be 2 and Q could be 14. Okay, P could be 3 and Q could be 13, and P could be 4 and Q could be 12. It doesn't matter what 2 pairs of values you use. You're just testing your understanding of this 4th rule, what I've called it the 4th rule. there's no real order to them. All right, so I hope that makes sense to you. Please like and subscribe. Thank you very much.